Last class, we talked about the word stoichiometry. Stoichiometry. You guys all know what stoichiometry means? What's stoichiometry mean? Okay. Stoichiometry. We drew this, for example, like if we have A plus B going to, what did it make? AB. Right? This is a chemical equation. A chemical equation. Can you guys all say that? Chemical equation. All right. And A represented some stuff, and B represented some stuff, and they come together and they form new stuff. Correct? All right. So this is called a chemical equation. What were this side of the arrow? What did we call the stuff on this side?
Reactants.
And over on this side we called it the products. All right, the reactants and the products of this chemical reaction.
Wait for anyone to come in.
Okay, in this chemical reaction, we have ones that aren't shown because it's, you don't have to put the ones in there because there's already, it's showing you that we have an A, so you don't have to say 1A. Does that make sense? And another one here that aren't shown, but they're there, right? And the stoichiometry of a chemical reaction is the ratio or the information about how many reactants come together to form products. Or you can also have a different kind of chemical reaction where the reactant breaks down. So here's an example of a chemical reaction. C2D, right? What does that 2 mean?
There's two of them.
Two what?
C's.
Two C's. Two C's. All right? Two C's. And how many D's? One. Two C's and one D. And in this chemical reaction, I'm going to show it breaking down into those as products. Do you see that? So this is the, what do we call it here now? The reactant. And these are the products. All right? This chemical reaction is decomposing. This chemical is decomposition. It's breaking down. You see that? It starts as one thing, but it breaks down into other stuff. Correct? This one here is forming a new compound, right? A and B are coming together to form a new compound. Right? And the stoichiometry is 1A combines with 1B to form 1AB. And that's the stoichiometry of this reaction. Would somebody like to tell me the stoichiometry of this reaction? Yeah?
1CD
1C2D.
plus 1C2D
Breaks down.
into 1C2 and 1D.
Of 2 C's
2C.
and a D. Does everybody agree with that?
I think you said it wrong. It's 2 C's and 1 D.
Oh, what did I say?
On the other side.
Here?
Yeah, over there.
C2D. 1 C2D
Oh, 1 C2. Okay.
breaks down
Sorry.
to form 2 C's and a D.
Got it.
Everybody okay with that? Let's try another one, okay?
Oh.
Okay? Here's another chemical reaction. Would somebody like to help me with the stoichiometry here? All right, Brady, let's hear it.
3EF2 2F2 plus 3E.
Okay, very good. Now, if this is a decomposition reaction, if we have an E and an F here, correct? An E and an F, 2 F's on every E, and it decomposes into these products here. The number of E's that I have on this side of the equation should be the same as the number of E's over here. Shouldn't it? Because if I have my pilots and my ships, right, and they're combined together, and then I separate them, now they're separate, I don't actually lose any pilots or lose any ships, correct? Does that make sense? So the number of the different elements should be the same. How many E's do I have on this side? 3. There's 3 E's. there's one E for every one of these things, but I have how many of them? 3. How many E's are on this side over here? 3. There's 3 E's there as well. Okay? How many F's do I have on this side? Well, there's 2 F's for every one of these things, but I have 3 altogether. Come on in here, guys. Come on in here. Somebody can sit right here. Can you scoot over? Here, let's move these pillows out of their way so that we can sit one more person. Yeah, somebody can sit right there. There's a little seat for you right there. Okay, there you go. All right. So we have 3 E's on this side, and how many F's did we say we have? 6. 2 for every one of these, but there's 3 of them. Okay? So, I'm going to try to make these things with my little chemistry kit here. Okay? So, here's my chemistry kit. And I'm going to put on, this is going to be my E. Alright, here's my E. Okay? And these white ones here are my F's. Okay? And I'm going to put on each E, how many F's?
6. Oh, 2.
2. On each E, I need 2 F's. So I'm going to do that like so. Alright? Does that make sense? Now how many of these do I have to make?
3.
3. I need 3 of these. Alright? Can somebody else? Here's 1, and here's 1, and here is one of those, and here is one of these. Whoops. Pass it along. Thank you.
Is Oreo coming in? I don't have those.
Okay,
They didn't
pass that
pass
to him. Pass that to him. There we go. Let's put it together. Now I have 3 of these. What is the chemical formula for this thing? Come on in here. Sneak right in here. Over here, Tommy Joe. You're late. Next time you're late, you get a little spanking. Okay.
I got that on video.
Oh, good. All right. So,
Just kidding.
What are what are these? These are what?
3 EFs.
3 EF2s, because this is the E and this is the 2 what? F's. All right. Now the reaction is supposed to happen. What's supposed to happen here?
They decompose.
They decompose, and so all the E's end up being what?
Separate.
By themselves, and then what happens to the F's?
They become just
They became little F what?
F2.
F2s, right? Does that make sense? Am I going to have enough? I should, right? In the end, I should have the same amount that I started with, correct?
But
Right? Because it should be what we call balanced. So here I have 2 F's, 2 E's, there's the 3rd E, and these should form a bond, correct?
oh, but then there's 3 F2s.
Oh, did I do it wrong?
You did 2 F2s.
3 times 2 is 6. Oh, this needs to go.
I was wondering what was going on there.
3 F2 is 6. Oh, 3 times 2 is 6. That's right. Sorry about that.
That's what I was raising my hand for.
All right? So, there we go. All right, so now I have my 3 F2s, right? And my 3 E's, correct? So I didn't have any leftover molecules, right? Any leftover entities, atoms or anything. What's that? I have leftover what? What are these things? Bonds, yes. The number of bonds that were between the atoms might be different. It might be different. Okay? That's true. All right. Now, I want to show you one more thing. So here I have my 4 spaceships that we used last time, correct? I have my 4 spaceships, and I have my 4 pilots, correct? And I said that for every spaceship, we needed 1 pilot. All right? Now, in the chemistry lab, when you go and do chemistry, you don't pick up 1 atom. Why can't you pick up 1 atom?
They're too small.
Too small. What you do is you weigh out certain amounts of atoms, right? You weigh out grams of atoms. Now, do you guys know how much a gram is?
Small.
Well, it's a lot bigger than an atom, right? In 1 gram of carbon, for example, you have over, how much is a Google?
100 zeros.
100 zeros?
Wow.
So you have about 1/5 of a Google in 1 gram of carbon.
1/20.
Lots of zeros, yeah. Does that make sense? So you can't count the number of atoms in the lab. So what you have to do is you have to weigh them out and compare them that way. All right? But I want to show you something. See this thing over here? This is a balance. If I move everything, let's see, move my balance somehow.
Let me see.
Why is this thing? Oh, there we go. Okay. See how it's balanced now? If I go, it's mostly balanced, right? Pretty close. If I go into the lab and I want to perform this reaction here, where I want to take A, and we'll say A are my pilots, and B are the spaceships, and this is a pilot with a spaceship, right? If I have a bucket of pilots, so here's my container of pilots, right? And I know I want how many pilots for every spaceship? One. I want one pilot for every spaceship. Okay? And if I go and weigh out from my bucket of pilots 4 pilots and I put them on this side, it's going to make the balance move to the left, correct? And then if I weigh out 4 spaceships, what did it make it
Whoa.
You made it go to the right side.
do? Okay? Don't I have the same number of pilots as spaceships?
Yeah.
Well, then why isn't it balanced? Okay?
Because there's more
Because-
pieces in spaceships.
Yeah, spaceships weigh more than pilots. Does that make sense? Very good. Let's pretend that I wanted to perform a reaction here with A's and B's. But now it's not pilots and spaceships, but it's these atoms, these reds and yellows, ATOMs. And I want to have a 1. Let's change these letters. Let's quick here. I'm going to call my red balls R plus white balls. Whoops. Form. What am I going to form? RW. Right? Same thing. If I come over here and weigh out my R and W's, are my R's and W's going to have the same mass?
No.
Who's going to have more mass, do you think?
Red.
The red, because they're what?
Bigger.
They're bigger. I was going to say because they're red, but... All right, because they're heavier. See that? So I can't go into the lab and weigh out... It does say, this equation says 1 red for every 1 white, and I combine them together and I get 1 red white, right? But I can't weigh out a gram of red and a gram of white and have the same amount of reds and whites. Does that make sense?
Mm.
Because why again?
Because they weigh different.
They weigh different amounts. Does that make sense? So, we have to have some way to fix that. We have to have some way to make it so that we can go into the lab and know how much to weigh out. All right? We need to know. What's that?
You said add an extra white.
Okay, I should add an extra white.
Maybe that would help it.
We need to know how many white atoms and how many red atoms, or how many pilots or how many ships. We need to know how many there are for every gram that I have. Does that make sense? We need to know how many atoms there are for every gram.
1 minute.
All right? So, we, as people in the world, have developed a number, a special number, that we use to communicate with each other and tell other people how many of one unit of material we have. All right? Kind of like a dozen. You guys know what a dozen is?
Yeah.
What's a dozen?
12.
Why don't they sell eggs, just go buy 1 egg or 2 eggs or 3.5 eggs? Why don't they do that?
Because it's too small for a family.
Because you can't have 3.5 because half of me one.
What do I have here?
Uh,
Oh, ouch! I have a pain in my neck. Because it's a pain in the neck, right? To have to sell 3 eggs, or 2.5 eggs, or 1.5 eggs, right? The farmer said, I'm not doing that anymore. I'm just going to sell them in dozens. You buy one or you don't. Go to Bob down the road. He'll give you 2.5 eggs, right? They stopped doing that. Does that make sense? They only work in dozens because there's what? Pain in the neck. That's right. And so we also have something like that in chemistry. It's not called a dozen, though. In next class, I'll tell you what it's called. Shh, 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 don't say this. All right, all done for today. See you guys tomorrow at 9 a.m.
It's exactly 9:15.